Go. So today we're starting our unit on concreting. We're specifically looking at the unit of carry-out concrete into simple forms. So while there's a whole heap of applications around concreting in the construction industry, it's its own Certificate 3 and Certificate 4 course that you can do. For the purposes of us, though, we're just giving you a really brief introduction into concreting and some of the processes you should be able to do as a handyman or as a builder. So really basic slabs. We're not expecting you to know the National Construction Code, specifically all the formwork and reinforcement requirements. We're not expecting you to be an engineer. So it's really just a matter of focusing on the processes around planning for, placing, and finishing a very basic concrete slab. So in this first lecture, we're going to be looking at the planning and preparing process, and that's going to help us look at the materials, the tools, the equipment that we're going to be using, as well as some of the safety considerations that we need to think about. At the end of today's lesson, I really hope that you're able to start your JSA documentation. So this should include the tools and materials. It should include some of the hazards specifically around these materials and this concept of crystalline silica and silicosis and the dangers associated there. And we'll really be looking at what do we need to do to get started with concrete. So here we go. The first thing we need to know that there are some safety issues associated with concreting processes. The first of all is when we are doing concreting processes, we are dealing with an extremely heavy material. And I say that because we are concreting large areas, so the volume of material we're using is usually quite large, and as a result, the materials then become heavy because there's lots of them. I'm also saying that manual handling is an issue because when we order our concreting materials, they either come in bags of 15 to 20 kilo sort of weights, or they come in 1-ton bags delivered from the back of the truck, or they come as bulk loose materials by the ton on the back of a truck. So they really come in bulk materials, and they're heavy materials. There's lots of them. Therefore, we've got the manual handling things to consider. So there's some of the basics. The other thing that a lot of people forget about is when we're moving concrete around and getting ready to place it, we quite often do that using a wheelbarrow. So we put this liquefied material, this liquid concrete, into a wheelbarrow, and we wheel it across the job site from the mixing point to the placing point. And as we're doing that, we've got this heavy material in the wheelbarrow that is liquid, so it's moving from side to side, and there's a lot of strain being placed on the body. The temptation there is always to increase the amount of material or the amount of concrete we've got in the wheelbarrow beyond its limit, and that obviously increases the chance of an injury. So what we need to consider is how we can control those processes to prevent us from getting injured. So it goes all the way from we receive the truck that has all the materials, how we put those materials away, the stacking and storing processes to make sure that's done correctly, making sure we're not twisting as we're moving from pallet to position in the workshop in storage location, make sure we're storing at appropriate height, so between knee and knuckle height, which is the power range, making sure that we're not forcing our bodies to bend too low or reach too high with these heavy materials. The second safety issue that I'll refer you to is crystalline silica. Now, crystalline silica is basically a chemical compound. Okay? It's a particle. It comes from stones. It comes from the quartz concept. So whenever we are at a quarry and we're digging up stone, then we are digging up this crystalline silica, and that fine dust that comes out of a quarry is filled with this crystalline silica. Crystalline silica is a key component of sand that you'll be receiving as part of your deliveries. It's a key component of the blue metal that you're receiving in your deliveries, and it's a key component of the cement mix that you receive as part of your deliveries. All three of those materials form the concrete. So all three ingredients contain this dangerous chemical or this dangerous material, and so we need to make sure we manage the processes there. Now, crystalline silica in its current day and age, we're talking 2020, is now starting to be promoted as the modern asbestos. Now, you recall the dangers asbestos has to people. You recall how terrible it was for the industry and how many people are still suffering from asbestos-related illnesses. And the processes that people now have to undertake when they're using or working near asbestos materials. Okay, so if it's considered to be that serious, then for us as students getting ready to work in the industry, we need to take it really seriously, because one day we will be the bosses. Okay? You will be the bosses of little construction companies, or you'll be site supervisors, or you may be just working with these materials, and you need to know the safety requirements associated with this hazardous material. Effectively, it's a really fine dust that when breathed in clogs your lungs, and as a result of that, it prevents your body from functioning properly because your body's not getting the right amount of oxygen. Okay, so it poisons your body in a sense, and just like asbestos, has a very short lifespan if you get silicosis. We're talking 6 months to 5 years is the typical lifespan for people that are diagnosed with silicosis. Now, I am aware that you may have done some work placements, and you may have gone out and you may have seen people, or you may know people in concreting or that do concreting that don't wear the appropriate PPE. A lot of that comes down to the fact that they didn't know when they were doing their training of the hazards and the dangers, and they're either not informed or have, for whatever reason, made a decision not to follow the recommendations that have been placed out. Now remember, we are guided by Safe Work Australia and therefore Safe Work New South Wales in the codes of practice that are put into place. And the codes of practice are very clear on this matter, that when we are dealing with concrete or quarry materials, granite bench tops for kitchens, for example, if we are cutting into that material, then we are doing so with a wet saw or with the appropriate vacuum devices. In addition, the recommended PPE says that we should be wearing a P1 particulate mask, okay, to stop us from breathing in those materials. Okay. Obviously, as with all dusty environments, you want to make sure you're wearing your long sleeve clothing to prevent the dust from clinging to your body. You want to make sure you're wearing your goggles to stop it from getting into the eyes. And if you're cutting into a material using a power tool, then you obviously want to consider the use of ear muffs as well. Okay, so, but particularly for this dust particle and the dangers associated, the P1 mask at the moment is the current recommendation. In these slides, you can see that there's hyperlinks to each of those items. These slides are shared with you and you have access to these links. I recommend you go to each of these pages to get additional information from these sources. These are the Safe Work New South Wales sources, so they're most relevant to us here in New South Wales. Click on those links to understand the specific procedures that you need to undertake to control and minimize these risks, and that needs to transfer across into your JSA documentation. Excavations is another safety issue that we need to consider in concrete. Usually we are digging a hole to place concrete in to reinforce either the foundation of a building, a pier for a building, slabs, beams, etc. So there's usually a fair bit of excavation involved. For our purposes, simple slabs, our excavations are very shallow. We're talking 100 millimeters for an excavation that we'd be working with. That being said, there are still some hazards associated with that and things that you can do to minimize it, and making sure you've got your physical barriers up to prevent people from accidentally making their way into these excavated sites. Particularly if you're doing deep pier work, there are some rules around that and making sure that the piers are actually filled in with concrete the day that they are dug. So you can't actually have an empty pier hole just sitting on a job site overnight or over a weekend unmanned. So there's some of the things to consider. You also want to consider, how can PPE help us with excavations and the hazards around tripping, for example? It's the difference between wearing a steel-capped shoe and a steel-capped boot. The boots have that additional support of the ankle, so if you twist and fall, you're less likely to sprain or strain your ankle. So there is that added benefit to wearing a boot, particularly a boot that laces up the ankle. The fourth hazard that I've got listed here, the top four that I'm asking you to consider for concreting, are the cement chemical burns. So cement is an alkaline chemical. It's got a really high pH of around about 14. Which means it can cause significant burning to your skin. So again, we want to try and avoid and minimize these risks. Now, the easiest way to minimize a cement burn is to not use cement, but that's not a reality for us. If we're doing concreting, then we need to work with cement. As a result, the next level of recommendation is, well, how can we prevent this cement from actually getting to our skin? Well, some of it comes down to PPE. So it comes down to the requirement that we've laid out to you that when we do our practicals for concreting, you are to be wearing long sleeve shirts, long trousers, closed-in shoes, and then all of the other PPE requirements that we set for you, especially around things like your goggles, your masks, etc. Okay, so following those PPE requirements can really have a benefit in preventing you from getting your injuries. So leave those with you. Have a look at those links, and I want you to then consider the information that's there and place that into your JSA documentation. So the next part of the planning process, once we're aware of the hazards associated, is to now start looking at, well, what tools do we need to use for these processes? And I've sort of broken this up into two separate lists. The first are the generic tools that are not really job specific to concreting. They're the sorts of things that we certainly use them for concreting, but you might use them for other purposes. Things like kneeling boards, wheelbarrows, shovels, rakes, brooms, spirit levels, straight edges, and gumboots. I'm not going to go into any detail in this presentation about those tools, but you need to make sure that you've listed them in the tools and materials part of the JSA documentation to say that, yeah, we will be using these. In terms of the task-specific tools, these are tools that are really specific to the concreting processes. And as a result of them being specific to the concreting processes, I'm going to go into a little bit of detail, not too much, just really brief bit of detail to help you understand what each of these tools are. And again, these should appear in your JSA documentation based on the ones in this list that we will actually be using. Now, in our school-based application, the Chute is only available if we're using the truck. So that will be part of the practical experience. The troweling machine, particularly the helicopter one, we're not doing a large enough slab. Sorry, excuse the bell there. We won't be doing a large enough slab to be needing to use a helicopter, but that's something you may experience at your work placement if you're working on a larger concreting project. So let's get started. The first one is the Chute. The Chute is basically a little half tunnel that helps to direct the concrete from the truck to where it's being placed. So it either, as you can see in the image there, goes directly from the truck into the formwork ready for placement, or if the place that we need the concrete is inaccessible by truck, then it goes from the truck down the chute into the wheelbarrow, and then the wheelbarrow takes it off to where we're placing the concrete. The idea of the Chute here is to try and soften the angle to prevent the splashing of the concrete, and also obviously given its extended range, helps to make sure we're able to put it in the right location. The truck only sits in a single position, and if we've placed the truck appropriately, by changing the length of the chute and the direction of the chute, we really hope that we're able to do a lot of the concreting process without having to manually handle the weight of the concrete in a wheelbarrow. Second device here is a kibble. Now, be very surprised if you're going to be using this in our school-based application, but effectively, this is a bucket. This is a really heavy-duty bucket that connects to a chain. You fill this bucket with the concrete mix, connect it to a crane, it gets lifted up into those high-rise applications, particularly if we're working in high-rise buildings, so that concrete can be placed on the roofs of buildings and on high stories, okay? You can see it's got a little built-in chute there that's being chained up, and so when it's ready to place, the chute comes down. There's a lever on the right side just over here. If I just turn my pointer on, you can see, turn my pointer on, there we go. You can see there's a lever here which opens the bucket up, enabling the concrete to be poured. This here is the chute, which enables the concrete to be directed and softens that angle to prevent that splashing again. The next tool across is a line pump. Again, this is for those larger applications, okay, where they're placing concrete in many positions. A crane might not be necessary, but the idea here is it's effectively increasing the range at which we can deliver concrete on a job site. So it's across long distances, and because we've got a crane arm, we can also go over physical barriers, things like fences and small buildings, okay, to make sure the concrete is placed where it's needed. Again, this prevents us from using that manual handling process of the wheelbarrow, which can cause significant danger, and obviously at the end of a large day of concreting is very straining. The next tool across is the vibrating poker. Now, the idea of this device is to compact the concrete. When we mix concrete in a mixer, we are mixing dry ingredients with water, and a lot of air gets pushed into the mixture. which prevents it from achieving maximum strength. This device is placed into the concrete while it's wet, while it's in its formwork. It's placed in, you turn it on, the little end point here makes a small vibrating motion, and that vibrating motion raises the bubbles to the surface of the concrete, therefore compacting and increasing the strength of the concrete slab. Troweling machines. Now, there are hand trowels, but a troweling machine is obviously a mechanical aid, and this could be either walk behind, like you can see in the image, or ridden, where it's like a ride-on mower, but instead of having blades that cut grass, it's got blades that trowel the concrete. It's effectively a fan where the blades are touching the surface of the concrete. It helps to smooth it out. They're really used in large slab applications. You wouldn't use it in a small 4 square meter slab, for example. It wouldn't be worth the cost of hiring this particular device. The benefit of using this is it avoids the trowel lines that are caused by rectangular trowels and the edge and the cutting into the slab that quite often happens. So it helps to give that really smooth finish. Because it's mechanical, it obviously works a lot faster than the average human can on their own. So now we start talking about those hand processes. The first of the hand processes I'm talking about here is a steel trowel. Now, a steel trowel made from steel. Okay. Now, it's specifically important that we remember steel because there are some other metal trowels and floats that are used that are not steel, and they have different applications and different purposes. So the steel trowel gives us a smoother finish than a timber float. Okay, because it's a metal, it doesn't draw water up to the surface and drag the concrete, so it doesn't stick to that wet concrete surface, okay, and helps to give us this really smooth finish. So this helps to give us this really smooth finish. Next across is another troweling or float device. This is a magnesium float. Now, this is again similar to the steel trowel. It doesn't drag the surface of the wet concrete slab. But the benefit of this one is magnesium is a lot lighter than steel. Therefore, it's less onerous on the person doing the finishing of the slab. It prevents them from getting physically exhausted from the weight of that trowel across a whole day of finishing. Now, in small application, the difference between a magnesium float and steel float probably wouldn't be noticed too much. But at the end of a 6-hour day of troweling and floating a concrete slab, absolutely the weight would make a very big difference. We've also got bull floats. Now, the bull float is really used for larger slabs. Again, this is particularly helpful if you can't reach the whole slab from the edge. It's got a really long handle. It's got quite a long base with a leading edge on both the front and the back so that you can push the concrete into position and pull the concrete into position in the floating process. Okay? Now, as you twist this handle, this mechanism here either raises this edge, the back edge, or it raises the front edge to become the leading edge depending on which way you're moving. Now, if we're floating in this direction towards the left of the screen, then you want this edge, which is called the leading edge, to be pointed up slightly so it can push excess concrete forward. Otherwise, your float actually digs down into the slab. Then when we're pulling backwards, we're going to the right of the screen, the back of the bull float becomes the leading edge, and it is then pulled towards you again to drag excess concrete. Now, the screeding process. Screeding is this process of using a straight edge, okay, a long straight bit of material, sometimes metal, sometimes timber. It rests against the formwork. So you can see we've got the straight bit of timber. It rests against the top of the formwork and is pushed back and forth, okay, and it sort of cuts the concrete effectively. Like it feels like a cutting motion, like you're using a saw. And then it drags the concrete to fill the gaps along the edges here, while also smoothing and pushing excess concrete down into the unfinished parts of the slab. Okay. The back and forth motion, it helps to fill those air pockets. Again, this is part of the compacting process. Helps to fill the air pockets near the formwork edging. Helps to push the excess concrete along the slab. And also helps with the leveling process. So if our formwork is level, if the top edge of our formwork is level, screeding using the formwork edge obviously then helps us to produce a level slab. Edging is another process that's involved in concrete placement, and an edging device or an edger is basically a small metal device, handheld, you can see, handle there. That's just the width of your hand, so it's only quite small. You can get larger ones. It's got a flat edge here which goes along the top of the slab, and then it's got this sort of bull nose along the corner and a slight downwards face. That there is the edge of the slab. So to prevent you from having a sharp corner on your concrete slab, this bullnosing process helps to give this nice rounded edge that's a little bit softer. Now, you use this at two different times. You will use this initially while when the concrete is initially being placed, just to drag any aggregate out of the way. It's not actually doing any edging. You just use it to make sure that there's no little rocks or aggregate pieces sitting where you're going to be rounding the edge, because if you wait till later, then that will drag and create a hole. So you do that right at the beginning while the slab is wet, just initially to cut into the edging. And then once the slab becomes a little bit plastic, so after a couple of hours of its placement, when it becomes quite firm and you've got the bleed water coming to the surface, you would then go across with the edging device again, and that's when you would actually complete the edging, smoothing off that edging, nice rounded edges, no dragging gaps whatsoever, filling them back in with a trowel where required. Grooving is another tool that is used, and again, we'll look at this during our processes point, but this is where we intentionally put crack points into a concrete slab. The idea is to weaken the slab where we want it to be weakened, so that if it does end up cracking, it cracks where we want it to crack, right along these control joints. Again, this process is completed after the bleed water has been reabsorbed, so once the slab has gone quite plastic, okay, so after that water process has happened, so you don't do it during the wet slab, otherwise it will just keep leveling itself back out. So that's the tools and equipment that we use specifically for concreting. Again, you can go to your JSA documentation, update them, explain how they're used, and start thinking about the risks that might be associated with them. And we'll now move on to those three key ingredients of concrete. The first being cement. Cement is a binding agent. It is a very fine dust. It is a binding agent. You add water with it and it becomes like a thick glue paste. And it glues together the two different aggregates that we use, the fine and the coarse aggregate. Cement contains crystalline silica, and as a result, there are hazards associated. It may cause irritation to your skin, quite alkalinic, therefore chemical burns. May cause serious eye irritation, again, chemical burns. May cause respiratory irritation. That's that fine crystalline silica dust we're talking about. And may cause damage to organs through prolonged or repeated exposure. Again, that's that crystalline silica process. So I've got a copy of an old safety data sheet that I've downloaded. This is from the product that we use, the Boral Cement Safety Data Sheet. And based on this version, these are the PPE requirements. It tells us to wear a P1 respirator, okay, so a particulate mask. It tells us to wear full body clothing. So you can see, in this case, it's overalls, but long sleeve shirt and long sleeve pants is also suitable. It tells us to wear gloves if we're going to be handling it, which is absolutely correct, and goggles as well. And that's minimizing the chance of our skin and our eyes and our lungs from getting in contact with this quite dangerous material. If it's managed, it's safe to use. Okay. For your assessment task, you actually need to source the most up-to-date safety data sheet for Boral, and you need to submit that as part of your task. And when you do that, you should identify the appropriate controls that have been recommended in the safety data sheet by the supplier and place that into your JSA documentation. Next along is the fine aggregates. Now we talk about aggregates. Aggregates are stone or quarry materials, and there are two types we use, fine and coarse. Fine are really small particles. They're bigger than cement dust, okay, but they're smaller than the coarse aggregates. The fine aggregate that we use here is sand. Again, contains crystalline silica. Basically, it is a mixture of sand or quarry dust, landscaping materials. There's a whole heap of different applications here, but again, there's a hazard associated with crystalline silica, damage to the organs through prolonged exposure. The same PPE requirements apply. Lastly, we then have the coarse aggregate. So these are the larger particles or the larger pieces of aggregate. We usually use blue metal. My preference for smaller slab processes is 10 millimeter blue metal. It's a little bit easier to work with, but 20 millimeter is quite commonly used as well, or any range within there is quite commonly used for slabs. Again, this contains crystalline silica particles, because it all comes from a quarry. Therefore, it can be dangerous. Crystalline silica, the hazard remains the same. For this particular one, you can see here that the recommended PPE is a P2 respirator. The difference here, with the respirator required is that specifically if you are cutting into this material. So if you're cutting into granite kitchen benchtops, you need to be wearing the appropriate filtration respirator. If you're not, if you're just working with it, not cutting into it, but you're mixing it into a cement mix, the particulate respirator is suitable for that. Okay, but check the details on your safety data sheet, because again, each time these data sheets are updated, this is from last year, each time they are updated, the recommendations may change. So obviously refer to the current information before you go off and do any concreting work. So that's the end of today's lecture. That's the introduction to the concreting process, the tools, materials that are required, the planning processes that we need to think about before we go anywhere near starting a concrete slab. Thanks very much, and I look forward to seeing you again for our next video. Thanks.